Are you a bit lost with fabric terms like capacity, tenant, workspace, domain, and you could be also wondering what is that OneLake then? Don't worry, since these terms and more are going to be demystified in this video. Stay tuned. Welcome to the video. My name is Aleksi and on this channel I cover Microsoft Fabric and Azure related topics. In this video we will continue our DP-700 exam prep series and a link to the entire playlist can be found in the description. This is the episode 3 in this DP-700 exam prep series, and in this episode we will cover the basics of Fabric terminology and structure. This episode aims to give you a solid foundational understanding of Fabric so that things that we cover later on in this series make more sense. Many of the topics that we mention in this video will be covered more in depth in later episodes. So don't worry if this episode doesn't answer to all of your questions about the structure and especially governance. Like in every episode in this series, we will start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Let's start by covering the core terminology and structure of Fabric. If you're working in a Microsoft Fabric environment, you will hear terms like tenant, capacity, workspace, domain and subdomain, etc. thrown around. And if you're not familiar what those terms mean in Fabric context, those conversations can feel quite confusing. But now let's break down this Fabric rabbit hole so that those terms don't feel so scary anymore. Let's start this rabbit hole from the Microsoft Entra tenant. Basically, if you're using any of Microsoft's cloud services, you have to have a tenant. You can think of a tenant as a dedicated playground that Microsoft has given for your organization to build those services into. Also, with the tenant, you get some identity and access management for your organization. For example, if the company you're working for is using Microsoft Cloud services like Microsoft 365 services that cover very commonly used services like Outlook, Word, Excel, and Teams, you know that you can use your organizational account, meaning basically your email, to log into all of those services, and that is made possible by having a tenant on the background. You could say that tenant is like a backbone for all of your Microsoft services. So, in very briefly summarizing, tenant is a control center for managing users and security across Microsoft Cloud services. There is also a possibility that organizations could have multiple tenants, but let's not complicate this example with those, and for now it is just good to know that that is possible. And like Teams and other Microsoft Cloud services, Fabric is also one of the cloud services provided by Microsoft, and it is deployed/enabled to be used for your organizational tenant like those other services. And at this point, I hope you already know that Microsoft Fabric is a data platform service provided by Microsoft. So this means that there is only one Microsoft Fabric per organization if single tenant is being used. That is the most typical scenario. Now the question could be, does it become very messy if entire organization is using just one data platform, and how you could have some separation per business unit or per person? Compared to other Microsoft services like Teams, it would be very problematic if entire organization would only have one Teams channel and everybody would be having discussions there. Also with Fabric, things can be separated, and the way to separate things in Fabric is to use workspaces. By default, every Fabric user gets their own workspace called My Workspace that can be used to build stuff inside Microsoft Fabric. Also, other workspaces can be created based on needs. For example, your organization might want to separate finance stuff from supply chain stuff by dividing things into their own workspaces. Then these workspaces will act as containers for different Fabric items that those specific business areas are using to build their specific data solutions that fulfill their business needs. And those data solutions on those workspaces require compute in order to work, and thus those workspaces consume Fabric capacity. And this is the next term that we are going to cover in this rabbit hole. Basically, capacity is the thing that powers up Fabric, and the size of the capacity determines how much compute power you have under the hood for your Fabric resources to use. And of course, bigger is better, but in this case also more expensive as well. And the capacity happens to be the main cost driver, and the majority of cost associated with using Fabric comes from running the capacity or capacities. If we come back to the workspaces, this means that every workspace has to be attached to capacity in order for you to be able to do anything within that workspace, because without compute, nothing happens. Also, in many instances, it is smart to have multiple capacities and not just rely on one. There are multiple reasons why this is the case, but for example, organizations could want to separate different countries to their own capacities due to multiple reasons like data regulations or cost tracking, to name a few reasons. Also, in many cases, it would be a good practice to separate production workloads from development and testing workloads to different capacities so that development and testing doesn't accidentally eat up your whole production capacity and cause issues in your production environment and with some business critical reporting and data solutions. Also, we have a possibility to group workspaces by using domains. This adds one more governance layer on top of the workspace and makes it possible for different business areas to manage their data according to their specific regulations, restrictions, and needs. Then in Fabric, we have also possibility to add subdomains inside domains that allows fine-tuning this grouping even more. And now finally in this rabbit hole we get to the juiciest part where the action happens. Inside every workspace we can create Fabric items like data pipelines, data flows, notebooks, event streams, and also we can create data stores like lakehouses. Every item in Fabric has to be created to some workspace, and these items are the building blocks of this platform, and different items provide different types of capabilities like for storing the data or transforming it. However, the rabbit hole doesn't end here, because inside some of those items we can create objects. The most easiest example is the Fabric warehouse, since to that data store we can create objects like tables, views, and stored procedures. And these objects allow us to fine-tune our governance and access to this very fine level. And now we have completed our entire picture here. And now somebody could be wondering that this looks quite complex. And what is the reason for all of these layers here? Well, the simple answer is that since we have only one fabric per organization, we want to have multiple layers that allow us to build and enforce governance and access management. And to those topics we are going to dive way deeper in later episodes in this series, but I hope this walkthrough helped you to understand the basics of fabric structure and how these different concepts relate to each other. Now, some of you who know a thing or two about Fabric could be wondering where is OneLake, and some of you who are newer to Fabric could ask now what is even OneLake? Well, that is going to be the next major topic in our Fabric journey. Let's start with basics. OneLake is this unified data lake for entire organization. And like the name implies, there is only one OneLake per fabric. If you are familiar with Azure Data Lake Storage, you can basically think about OneLake as SaaS or software as a service version of Azure Data Lake. Basically, OneLake is built on top of that same technology, and Microsoft has just made it easier for organizations to use without needing to manage Azure infrastructure related to managing data lake there. And like with Azure Data Lake, we can store files and tables to OneLake, and the default data format for tables there is the Delta Parquet format, that is this very powerful open source format capable of handling huge amounts of data. This is the same format that is used, for example, in Databricks, that is another huge player on data platform scene and can be found on Microsoft Azure. And like with Azure Data Lake, storing data to OneLake costs money. And in Fabric context, OneLake storage is also generating costs along with capacity consumption, but usually these costs are significantly smaller compared to the capacity costs. All of the things that we have mentioned until this point about OneLake could be more or less achieved by just using Azure Data Lake. But OneLake has some aces in its sleeves, and one of the most notable and interesting of those is the possibility to create shortcuts. And what are these shortcuts, one might ask? Well, these shortcuts are a way to show data in OneLake that is actually sitting in some other place physically. In other words, this is a way to virtualize data using OneLake. This feature is very powerful in many ways, but one of the main advantages of this method is to eliminate data duplication that tends to happen when organizations move their data from one place to another. Also, the big vision behind these shortcuts is to make OneLake a portal to all the data that organizations have. Currently, Fabric has already shortcut possibilities to many different external systems, and to name a few, you could now create a shortcut to AWS S3 Bucket, Microsoft Dataverse, or to Azure Data Lake. There are also other external systems that are already supported, like Google Cloud Storage. Also, some data store mirroring capabilities in Fabric utilize shortcuts as the method that brings the data to Fabric, but we are not going to dive into mirroring in this episode. Okay, cool. Now we have some data in our OneLake, and now we would need to access that data. How do we do that? The answer is that on top of OneLake, we have a serverless compute layer that is powered by Fabric capacity that provides the compute for Fabric. And like in many modern data platforms, the compute and the storage have been separated from each other, and so is the case with Fabric. This compute layer provides many different interfaces for accessing that data in OneLake, and we have interfaces like Spark, TSQL, KQL, and analysis services that can be used to interact with data in OneLake. Also, since OneLake uses Azure Data Lake storage architecture, we have possibility to use interfaces like ABFSS to access the data in similar way we could access data in Azure Data Lake. Then we have to have some data consumption activities that use this compute layer to access the data stored in OneLake. So on top of the compute layer, we can add a layer for data consumption. And from this consumption layer, we can access the data in OneLake using the compute layer. The most typical way in the Fabric context is use one of the tools that Fabric offers, like data pipelines, data flows, notebooks, or event streams that are also in the scope of this DP-700 exam. Also, Power BI is one very typical way that the data is accessed. Of course, the data consumption could happen from a third-party service or application, or maybe user could be accessing the data using one of those interfaces. And now, some of you could be wondering, why do we need OneLake? Since we have those data stores in Fabric like lakehouses, warehouses, and event houses, and we can just store our data there. Well, when you're storing your data to those data stores, you are actually storing your data to OneLake, and those data stores are just the primary way of accessing the data in OneLake. And even though data formats in those stores might look different, all of them use Delta Parquet files in the background to store their data. The exception here is of course Lakehouse, where you can store some raw files as well, but the tables in Lakehouse are also stored as Delta Parquet. This same thing applies to warehouses and KQL databases as well, and all of that data is Delta under the hood. But we are going to dive way deeper into all of those data stores in this series, so things will be made a lot clearer in later episodes. This wraps up the theory section of this video, and next let's take a look at these concepts that we have covered in Fabric to get a better idea about them in practice. Before we open Fabric, I would like you to know that I spent a ton of my free time creating these videos for you. And that is why I would like you to hit that like button and subscribe to the channel for more DP-700 and Fabric content. This doesn't cost you anything, and I would highly appreciate that. Also, if you would like to support the channel with a cup of coffee, you can do so by clicking the Buy Me a Coffee link that can be found in the description. And huge thanks to people who have already supported the channel with the small donations, since those donations help me to provide content for free and improve my production quality. But now let's go to Fabric. And now we are in Fabric, and this is the main UI that opens up when you open the Fabric portal. And here we can see all of these different Fabric experiences like Power BI, Data Factory, Data Engineering, Data Warehouse, etc. But basically these experiences don't really matter, because all of the Fabric tools can be found in every experience. But basically when you open one of these experiences, like Data Engineering, you get the tools here that you will most likely need to build your data solutions with that experience. But yeah, those experiences are quite a nice way to provide these different developer experiences, even though they don't matter that much. And now when I open this Data Engineering developer experience here, I can see that I would be able to create some items like lakehouses, notebooks, environments, Spark jobs, data pipelines. And these are the tools that the data engineer would most likely need to build his or her data solutions using Fabric. And here on the left bar, I can see that I have my workspace open. And every Fabric user gets this my workspace by default. So you have this own workspace where to build things here in Fabric. And now I would like to change the workspace to this new DP-700 workspace that I just created here. And I can open up that workspace. And now I have switched to this DP-700 workspace where I have some different items that I had in that previous workspace. And I have created this workspace to be this kind of a dedicated container for everything that I will be teaching in this series. And to this workspace I can create all the items that I'm going to need in this series. And I have created just a lake house and a warehouse to this workspace because I'm going to use them to demo things today. Next, we can talk about Fabric capacities. Basically, Fabric capacity is this capacity resource that is created to Microsoft Azure. And here I can see on my Azure subscription that I have created this capacity here. And it is just one of the Azure resources available in my resource group in Azure. And we can open up that capacity and see how does it look. Basically, we don't have many options here. This just tells where is this capacity located and what kind of tier we are using for this capacity, or what is the size of this capacity. Here this says F2, and we will come back to these tiers quite soon. And here I could actually start my capacity because now it is paused. And if I would click resume, my capacity would start up and it would start to generate costs. And now we can see that the capacity is running. But yeah, I'm going to pause this capacity since I'm actually using a trial capacity in my workspace and I don't actually need this capacity right now. And here we can actually see this tab where we could change the size of the capacity, and we can open up that. And we can see that we have different tiers of this capacity, and we can see that the price and the capacity units increase with every step. And here on the right, we can see the estimated monthly cost for each capacity if we would run it all the time. And we can see that things would get quite expensive if we would get the biggest capacity that is available here. Also, it is good to keep in mind that Microsoft offers these capacity reservations so that you could commit for using a Fabric capacity for a certain period of time and then get a discount from these prices. So basically, you are just seeing the starting prices here for these capacities. And one thing to note about these capacity tiers is that most of the fancy features in Fabric, like using AI features like copilots, require this F64 capacity to be enabled. So basically you are paying quite a lot if you want to utilize those AI features like copilots and some other features that are locked behind this F64 capacity. And if you would like to create your own capacity to Azure, you can just create a resource group that I have created here and then click this create button and then just search for Fabric capacity here, and here you can find that and then start to create this Fabric capacity using this portal. But yeah, I'm not going to create a new capacity right now, so let's exit this. Then, like I explained before, every workspace has to be attached to capacity in order it to work. So basically we need compute for every workspace. And how do we manage that? And we can open up this settings tab to manage those things. And keep in mind that this is behind admin portal. So you would need an admin access to Fabric to do this, or very elevated rights. And here we can basically manage many different things related to Fabric and enable some preview features, for example. But now we're interested in workspaces. So let's open up that tab. And here we can see my DP-700 workspace. And we can see that we have attached that workspace to this trial capacity. And here we're able to manage this capacity and maybe assign it to a different capacity if we would want. But basically now it is using this trial capacity here. But here we have the option to select the Fabric capacity and then just select the capacity that we want to attach this workspace to. But yeah, this is the way how you would change the capacity to a workspace if you would like to do so. And remember that every workspace has to be always attached to capacity. Next, let's go to this domain tab of our admin portal. And here we have all the domains that we can see in this tenant. And I have to blur out some of these domains here because those would show some of my colleagues' names here and I don't want to show them on my YouTube channel. But yeah, I have created this Aleksi test domain, and now let's open up and manage that domain. And remember that we could assign workspaces to domains to logically group them together. And here we could actually select workspaces that we want to assign to this domain. Basically, we have few ways how we can assign workspaces to this domain. We have the possibility to just manually search the workspace by name and then add them to this domain. Or we can assign them by using the workspace admin. Basically, this would assign workspaces to this domain based on the domain admin. And then lastly, we can assign workspaces based on capacity, so that workspaces in certain capacity would be assigned to this domain. But now I would like to assign the workspaces by name and then just search the workspace here. And here I would be able to find the workspace that I have here. But I'm not going to assign this to this domain now, because I have also created this subdomain under this Aleksi test domain. And like I explained previously, we can also assign workspaces to subdomains to fine-tune this logical grouping even further. And here we would be able to assign workspaces by using the same options that we had for the domain. And now we can actually assign our workspace to this subdomain and just see how does it look. And now we can see that we have assigned one workspace to this subdomain. Next, let's talk about fabric items a bit. So now I have that DP-700 workspace open here, and to this workspace we would be able to create some new fabric items, even though I have already created few items here like the lakehouse and warehouse. We could click this new button here and then start to create new items, like for example a data pipeline or a data flow or a notebook to this workspace. And then those items would be part of this workspace, and we would be able to use those items in this workspace to build our data solutions. And also we have the possibility to create data stores to this workspace that would then store their data to OneLake, like I explained previously. But yeah, we will be creating a lot more items to this workspace in later episodes. But now let's close this new item tab here and let's open up one of these data stores, and let's start with Lakehouse. And like I explained previously, Lakehouse is this data store that supports storing files and tables. So we have this section for tables and then we have this section for files. And under this file section I have created this folder called episode 3. And under that we have two folders. In this source folder, we just have one CSV file, and we can preview the file here. This just illustrates that we can store raw data to Lakehouse. But this other folder is a bit special. If you can see that little icon there, that means that this folder is actually a shortcut. And I can open up this folder and see where it leads. And this says that this file is in Azure Data Lake, and we can preview this file. And it says I'm a file in Azure Data Lake. And what I've done here, I have actually created a shortcut by using this UI here and clicking a new shortcut, which will allow us to create a shortcut to this Azure Data Lake storage. So I have already done that, and this is actually pointing to this storage that I have in this same resource group where I have that capacity. And I have created this shortcut to this data lake container in this storage account. And in this storage account I have the data lake container, and in that container I have this TMP folder, and that file that I just showed to you there is actually sitting in this folder. So it is not actually stored in OneLake. So this is an example of OneLake data virtualization by using a shortcut that I mentioned in the previous section. But yeah, we can also create shortcuts for tables. So we have possibility to create a new schema shortcut that would also point to these same places, but then we would have to use Delta Parquet format to bring Delta tables to Fabric using these shortcuts. And also under this episode 3, I have this one table. This is not shortcutted table, and I have just loaded in that CSV file that I had here to a table. And in this table, I have the same data, but now in Delta Parquet format stored in OneLake, and we're accessing that data using this lakehouse here. Remember that all the data basically in Fabric is stored as Delta Parquet, except these raw files that we can store here in the lakehouse. But yeah, here is the CSV data in the table format. And now let's go back to our workspace and let's open up the warehouse. And warehouse in Microsoft Fabric is this very traditional database looking data store where you can store tables and create stored procedures and create views like you could in a traditional SQL database. But remember, even though this looks like a very traditional database and we would be able to query these tables using TSQL queries, for example, selecting top 100 from this table, this data is also stored as Delta Parquet files in OneLake, even though we are using this TSQL interface for accessing that data. But yeah, this wraps up this demo/tutorial section of this video. And next, let's have some questions about the topic that we covered today. Let's start with this question. Which of the following best describes the role of capacity within Microsoft Fabric? Is it A, capacity is optional and only required for creating advanced data models? B, capacity powers compute resources for workspaces and is the primary driver of costs in Fabric. C, capacity is used exclusively for storing data in OneLake. D, capacity governs user permissions and access management across all Fabric workspaces. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. And the obvious answer for this question is B, since capacity provides the compute resources necessary for all activities in Fabric, such as creating and running data pipelines, notebooks, and accessing data in OneLake. It is also the primary cost driver in Fabric. And what comes to the incorrect answers, A is incorrect as capacity is mandatory for any activity within Fabric, not just for advanced data models. C is also incorrect as data in OneLake is stored independently even though capacity is used for processing tasks related to that data and needed for accessing it. But capacity can be used for other things in Fabric as well that doesn't access that data in OneLake at all. D is also incorrect since Fabric capacity provides mainly compute and not user permissions and access management. Next, let's try a bit more challenging question. Your organization is planning to adopt Microsoft Fabric for its data platform. Which of the following statements are true regarding Fabric structure and its relationship with other Microsoft services? Choose 2. A single Microsoft Fabric instance requires multiple Microsoft Entra tenants for its different services. B, workspaces in Fabric act as containers for different Fabric items that are required to perform data processing within Fabric. C, each workspace in Fabric can function independently without being tied to a capacity. D, OneLake serves as a unified data lake for the organization built on Azure Data Lake technology and supports the creation of shortcuts for external data sources. E, Fabric domains allow organizations to bypass the use of tenants for workspace access and governance. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer for this question are B and D. B is correct because workspaces are essential in Fabric for organizing and isolating different business workloads. They act as containers for data pipelines, lakehouses, notebooks, and other Fabric items that are used for creating data processing logic. D is also correct since, like I explained, OneLake is a unified data lake for the organization. It is built on Azure Data Lake technology and introduces shortcuts for visualizing data from external sources, reducing duplication. Then we have our incorrect answers. A is incorrect since Fabric requires only one Microsoft Entra tenant to function. C is also incorrect since every workspace has to be attached to a capacity. Then lastly, E is incorrect since domains don't allow bypass of the use of tenants for Fabric management and tenant is always required. And that is all for this video. I hope you now have learned about the basic structure of Fabric and know the basics of OneLake. I hope you have learned something new in this video. If you'd like to continue learning, check out the next video in this series. Now I thank you for watching and see you in that video.